Okay, I hope I will clear away everything in this video. So let's continue. Previously we stopped at trying to we stopped at deriving our particular integral, but I also haven't said that this particular integral also can reflect that is that evidence to prove that it is moving in the opposite direction compared to the previous you know configuration where we move from here to here. So now from here to here, it should be in the opposite sign. So therefore, yeah, previously was f over k, now it's minus f over k. So this is another form of checking, but nonetheless, yeah, just to let you have a feel of it. And then now we solve for the a1 and b1, a2 and b2, sorry. So yeah, and just to let you know that the subscript 2 is actually describing the motion from the position x2 back to x1. So as I mentioned earlier, very earlier ago, the subscript 1 is actually um, you know from means x moving from right to left. So now x2 is from left to right. So I actually didn't write it down. Maybe I should write it down. Yeah. So I have this set, and then yeah. So I've clearly defined the x2, and take note that this x2 is the distance, not the position. Okay, we have a little, yeah, a little complicated stuff over there. But let's solve for a2 and b2. It's the same thing. Everything goes the same. Okay, everything works the same. Okay. We said, but for now, this time around we do t prime. Okay, t prime is just another notation to define time. At we set at this point, the time for this we can actually set it as equals to 0. Okay, but it's a different time domain from this time, since therefore when you move from here to here is t, but when you move from here to here is t prime. Therefore, we can initially take that this t prime is equals to 0, and we can analyze from there. So in other words, what I mean is that if because we split it up, we split the amplitude into two graph, right? This is one cycle. We at first we do this cycle, so we start from here to here. Now we start from here to here. We can in some sense say that we are starting the graph. Okay, we are starting the graph from here to here. I mean from here to here. So therefore, at time 0 is actually this point, which is what we call the x2 position. Okay, so that's why actually this is t prime, time prime. Okay, so this is what I want to convey over here, and then yeah. So with this in mind, we set our boundary condition now in order to solve for our a2 and b2, and t prime is equals to 0, same thing, but rather that one special thing is that our x2 is equals to x1, because our distance, we will assume that the distance for this x2 is the same as the distance for this x1 over here. Okay, we will assume everything is the same, provided that you already know that, when it springs back, you wouldn't reach back this position, you will reach back slightly, at this position, but we will assume that the symmetry is the same. So to simplify things, because they actually uses the same equation, so x2 is equals to x1 is much the legit, because x1 itself, it depends on the position of x1, so everything is still in terms of a variable. So whatever time and natural frequency you sub in, it depends on your, it depends lah. Okay, so it depends on them, so it doesn't complicate things much. Given that if let's say our vibration is kind of like little, so it is still assumed presumably acceptable. But yeah, let's go back here. So we will assume that x2 is equals to x1. So therefore x2 is equals to x1. We just sub in x1 over here. So this portion is x1, which we found earlier. Okay, if you don't remember, our x1 is this portion. It's the same thing as this thing. Okay, so you just simplified it, and then oh yeah, this omega n t prime is equals to pi radian. So as as been shown here, our t prime, we are starting from here. So therefore, we can actually say that in terms of the whole system, we can say that this is pi, and therefore everything becomes cosine pi. Yeah. Okay. Yeah. Sorry. No. Since that's now, as I said earlier, for t prime, our graph starts from here, right? Our graph starts from here and then start to oscillate. But now we are in terms of omega t. Okay. See? Boleh. But anyway, hold on a while. Okay, so I didn't define much for the t. So that actually this is t prime. Okay, so let me explain why this is it. Because when you sub in for the x1, if you go back to x1, the previous thing, x1 itself, the t is actually in terms of t, the actual t, not t prime. So when you sub in 0, is actually is in the particular t domain. Okay, now we're talking about the particular t prime domain. Okay, we're talking about the t prime domain, and therefore it's like a, let me see. It's like a t is actually t prime. Okay, in this case we sub in t prime as t. Okay, so x1 now is the previous first part we are doing. We derive that cosine omega t. But now since we are dealing with x1 is equals to x2, and when we sub in the t, we sub in t prime is equals to t. So when t prime is equals to t, the whole this thing that belongs to, so this whole thing becomes pi. Okay, it's like a initial condition now. So instead of starting at t equals to 0, typically when you start at t equals to 0, you sub in 0, right? But now we sub in pi because we are starting at pi. So this is the meaning behind it. Okay, it's a little abstract and a little complicated. So just to reinforce again, previously we derived x1, and then the t itself is in the time domain, which is in terms of the do we have any graph over there? Okay, anyway, so it's in terms of the time domain. It's in terms of the time domain starting from here, right? T. But now when we're talking about t prime, we're starting from here, pi. So you sub in t prime into t. Okay, so previously is when you sub in x1 is actually t, right? So now you sub in t prime, so it becomes t prime over here. Okay, so t prime, omega t prime is actually pi because you're starting from this position. You're starting from this position. You assume that this is the so-called the t when like t equals to 0, but now is t equals to pi is the initial condition for the system. It's a little abstract. Yeah. So maybe you give me a minute. So previously, we're starting from here, t equals to 0, and it comes down all the way. So it makes sense that everything is in terms of t. Okay, but now we are starting from here to this position. Okay, we're starting from here to here, and therefore it is legit that we start from pi, right? So therefore this is it. I can't think of any more argument, but rather that should be enough to explain. And I just check the time is 9 minutes, so I'll just clear away all this, and then the last part I'll just summarize and then derive the final answer. And yeah, so I'll just continue first. So when you sub in omega n, t prime is equals to pi, okay, where we assume that this is the initial condition for this sector. We will eventually rearrange and everything like that. Cosine pi is -1, so eventually you will get -1 multiplied by this thing you have. Okay, you eventually you get this lah. Okay, dude, that's it. And then you sub x2 back. Okay, so this is x2 equals to x1, which is just now this one. But remember that our complementary function, our general solution that x2 is also equals to this complementary function plus particular integral. So this thing over here is equals to this thing over here. It's the same thing, okay? So this is what it explains lah. So now we can start to solve for our b2 and a2. So similarly we sub in our omega n t prime is equals to pi, our initial condition. Okay, assuming that we're starting from pi. Okay, assuming we're starting from pi. Assuming that the graph starts from pi also. Yeah, hope you understand. And then and rearrange, and then when we sub in this one will become 0, and this one will become minus b2. Okay, -1 times b2 equals to minus b2, and then minus fk. So this is this, and then you rearrange, you bring b2 over, and you bring, because this one is already found out already right, this is this. So you just, and this is minus b2 minus fk. So this portion reflects this portion, and this one reflects this one. Okay, so you rearrange the whole equation, you'll eventually get b2 equals to this. And then now we solve for the a2. For a2 wise, assume t prime is equals to 0. Okay, now for this case, my answer for if you go to my notes, the answer is a little different. I don't know why a2 is equals to 0, but I have derived this situation. I think it's quite legit, so I'll just continue first. So t prime is equals to 0. Okay, I assume that not omega t prime, but rather t prime is equals to 0, because we will assume that when at this point, this is t prime, right? At this time, this is t prime. We assume that there will be nothing much. We will assume that this is the initial condition. So we assume that t pi is equals to 0. Okay, t prime is equals to 0, and therefore when you sub it in, cosine 0 equals to 1, and then you get this one, and then eventually, since omega, the natural frequency cannot be 0, a2 is equals to 0. Okay, so this one is the velocity of the system, the t prime, because at this point, when you're starting to spring back, at this point you have a lot of potential energy, you have no velocity at all, your velocity is equals to 0. Therefore it makes sense just for the case that when t point is equals to 0, because t point is in another time domain, as I said earlier. So I would assume that is that. It's a little complicated between t prime and omega t prime, because omega t prime, it becomes pi, it is equals to pi, and then my t prime here is equals to 0. Maybe I will explain what the lecturer has written for that. He actually say that from, okay, so this is not included over here lah. Okay, I didn't write over here, but I'll just explain here briefly. So he says that x2, okay, x2 is equals to this thing, and then is equals to this whole thing lah. Okay, and then since a2 is equals to 0, b2 is equals to this, and he didn't derive any a2. Yeah, apparently he didn't derive a2, I believe. Yeah, I don't think he derived a2. yeah, so this is why I pop up this idea. Okay, so hope it's kind of like give me a moment, hold on. I just found out why not we don't put it as t prime is equals to 0, but rather omega t prime is equals to pi. Okay, okay, so omega t prime is um, equals to pi, and therefore when you sub it in, this one it will become minus omega natural frequency a2 minus, because psi pi is equals to 0, and therefore the negative side won't do anything lah. So therefore omega n cannot be 0, a2 is equals to 0. So I think this will be more legit. Yeah. So yeah, and then since we know a2 and our b2, let me see. We sub in our a2 and b2 over here. 14.5, step 14.5. We have a lot of steps. Okay. So and then just sub it in over here. X2 is equals to x1 minus. So this portion here reflects the this portion here, x1 minus this one. Yeah, okay, it's just okay. We just sub in b2 and a2. Okay, sorry, paiseh. So b2 is this thing. Okay, it's this thing, x1 minus 3f over k. You just sub in over here, and then since a2 is equal to 0, everything becomes 0. So it's just plus b2 cosine minus fk. So this is what it is written over here. Okay, and then now maybe in the next video I'll just continue. Bye bye.